I'm Iwan Morus. I'm a professor of history here at Aberystwyth University, and my main speciality as a historian, I'm a historian of science, and specifically of Victorian science and British Victorian science. Grove, the Swansea boy, he's born in Swansea in 1811, comes from a kind of, sort of good, solid Swansea merchant family. Originally trained in law, and he eventually becomes well known as a lawyer and a judge. But I mean, during the 1830s, 1840s, he becomes interested in experimental natural philosophy. For a while, he's professor of experimental philosophy at the London Institution. He first makes a name for himself right at the end of the 1830s by inventing a new kind of battery. Electric batteries, voltaic cells as they would be called during this period, have been around since 1800. The first cells are invented by Alessandro Volta in 1800. But they tend to sort of run out quite quickly. So the search is on for a good, powerful cell that will essentially last long enough for you to be able to do things with it. And Grove, at the end of the 1830s, develops such a cell, a nitric acid cell. It's constant, it's powerful, and this is at just the point in time when the telegraph industry is just about starting to take off. Charles Wheatstone and William Fothergill Cooke take out the first patent for an electromagnetic telegraph in 1837. And the Grove cell, as it gets to be known, becomes the standard battery that then is used for the telegraph industry. So Grove makes his name in the first place for that, which is what actually gets him his job as professor of experimental philosophy at the London Institution. He's interested in things like batteries. He's interested in trying to figure out how batteries work, where the power comes from. And out of that work, a few years later in 1842, he invents, what he really thinks of as, so to speak, a philosophical toy. A wonderful instance of the correlation of natural forces is what he describes it. And it's a battery, he calls it the gas battery, which, rather than having a liquid and acid electrolyte, has gaseous electrolytes. So it's a battery that consists of platinum, zinc, and oxygen and hydrogen, and it produces a current in just the same way as any other battery. One of the reasons that Grove is fascinated by this, and this is in a way what he means when he says it's a wonderful instance of the correlation of natural forces, is that one of the standard ways during this period, around the beginning of the 1840s, in which you'd sort of measure the power of a battery would be by using it to decompose water. And of course, the gas battery does exactly the opposite. It produces electricity, and in the process of producing electricity, turns the gases into water. And then so the electricity is being produced, and at the other end of the circuit, so to speak, you have gases being decomposed, so water being turned back into gases. It's that kind of balance, I think, that Grove thought was kind of interesting and fascinating, and meant that the battery was a very nice example of the interconvertibility of forces, which is what he was particularly interested in. And a few years later, in 1846, he was going to write a book called The Correlation of Physical Forces, exactly about these kinds of transformations. People like Grove are also well aware of the fact that sooner or later, coal is going to run out. But Grove will say, well, that's going to be, more or less explicitly says this, that's going to be their problem when it happens, not something for us to worry about now as to what we will do when that great granary of force runs out. So on the one hand, Grove is quite interested in the economic potential of his batteries. He knows that they're not economic yet, and he himself isn't particularly interested in pursuing that. It does seem for a while that electrical locomotion is going to take off. I mean, in the 1880s, 1890s, you would have electrically powered trams and streetcars in American cities and European cities. But yes, that technology is then overtaken in the early years of the 20th century by the internal combustion engine. Oil, relatively speaking, is cheap. So what you see emerging during the 20th century is an energy economy that's basically predicated on the existence of large quantities of cheap oil, cheap gas, which of course is what has led to the predicament that we find ourselves in now, when on the one hand those sources of energy are no longer cheap and are certainly no longer limitless, and we also now know what people didn't necessarily know 100 years ago about the kind of profound and serious environmental impact of using those sorts of sources of energy.